Okay, hi y'all. I'm going to do my lightning talk on Docker. A little bit about me. You might have seen me in the UPL. I sit there for hours. You might have seen me. I help run Mad Hacks, and I'm also part of Girls Who Code. That's where I exist among students, and I'm Grace. So think about this. You're going to a company. You want this specific company, you've done your applications, you've gotten there, you sat down with your first Python project that they've given you to test, and you go, okay, I can do this, I can do this. I can clone my project. I can download it. I can try to run it. And as soon as I try to run my project, Python main.py, maybe it'll work. I have imports, module imports, and we all see that. Like, this is so annoying. We would like to have all of our imports just not work, or just, we want them to work, but not have to deal with this every single time. And most students have run into this where you just are pimp installing everything that you need so that your stuff works. And sometimes it takes time, but usually it's fine. Usually it goes, and then you can run your program, which is, in this case right now, running Dijkstra's. So there are a couple ways to go about this. You want to make your Python project work for every machine. You could potentially get a virtual machine, get something from like Google's list of machines and be like, oh, that's the machine that I want to use, and that's the machine that's going to allow me to write independent code. But that's kind of a lot of work because you have to actually initialize a machine that's on the cloud. Or you could use a virtual environment. Like, virtual environments are like venv, when you like do start bin/start/activate. You could do that, but that's not cross multiple. It's not. You cannot take that across multiple machines and have that work. You have to install that for every single machine that you're doing, and because of that, there is this wonderful solution called Docker. Oh yeah, VM versus VE versus Docker. So what Docker does is it builds images and containers, or it builds images, and the images run containers, and each container is running a tiny computer, a tiny kernel, which is like part of the operating system that it runs on, just enough to get your stuff working, to get your stuff and so I broke it down to like why we need to use container, and for me it's like it works across, like if I were to hand someone another image and say, hey, run this image, it's going to have all the stuff that it needs, it's going to run exactly how they want it, and then another person can easily just run the program. So first, you want to make sure you have Docker installed. If you don't have Docker installed, install it. You should see your version. You should see what is happening is it's running. It's showing you all the containers that you have when you run Docker PS. And then when you run Docker images, it will show you a list of all the images. And I guess it got cut off before that ran. So most Dockers are based off of a Docker file. So you need a Docker file, and you need to specify, oh, actually, yeah, you also need a requirements txt first. You want to specify, oh, these are the requirements that I want to use every single time, and you're just saying like, this is the exact version I have, because if someone updates the project in the future and changes the version, you want to know what version it was on, or what version it was working on, so that when you're doing future projects, you know exactly how to update and how to run that project if it's starting to get a little older. Oh yeah, so in this case, you need a Docker file, and this Docker file, you will write all your instructions to build your image. And then once your image is built, you use those to build your container. And so in this example, this is a more complex graph on how it works. Basically, when you're building a Docker image, you want to, you Docker build and then the image builds. So like you see all of the things that you put in your Docker file build out in the terminal, and then you do a Docker run, and then now you've built this image, and now you want to run this image in a container, and then there are things where you can put it into a registry for other people to use, which is up there. I've used registries when other people have written images that I want to pull, stuff like that. So this is where you actually write your instructions. You want to say, these are what I want. And in this case, I'm writing Python 3.12 Slim. And you can see that I'm like running that because Python 3.12 Slim has one of the lowest footprints in terms of technology. It's a really good one to run. I'm choosing my working directory. Inside the container, you have folders and directories worth of stuff. I want to create my own folder in which that I'm running Docker intro. Therefore, and then I want to take all the files that I currently have and move it over to that container, in which, like, in this case, you see PyProjectHoml and requirements.txt are files that I currently have in my current directory that I want to transfer over. Now we want to build all of those requirements. We want to build, all of the stuff that we put in that requirements.txt. So networkx and that netplotlib, we would like to build that. And then we're copying the rest of our application. Sometimes I like to do this just in case I've missed a file, or like just copy everything so that everything exists. And then we want to, so this piece is really cool. You can use this piece to run the folder name as the like Python 3, and then it'll like run your program, and you don't have to type in like Python 3 main.py. But yeah, it's all the pieces that you would need in order to create a Docker file. And so we're back here. We have created our Docker file. It now exists. And so we're like, okay, well, we need to do our Docker run. We need to do our Docker build and our Docker run. And so our Docker build is in this directory at the name, I called it name, -t name is called name. And then after that, you see every single thing that happened in our Docker file. Like each item in our Docker file is shown as it's getting built. And then now we're running. We want to remove extra cache. We want an interactive entry point in bash with the name. And then now, all of a sudden, you are in your own container. And so now when you run Python main.py, whoa, you don't have to install any dependencies. They're all gone. The Docker already built your dependencies for you. And so this is where most people are like, oh, I know Docker because I can build images and run containers. But there's something even cooler about Docker that I wanted to show. So basically, what I'm going to show is I'm writing my Python my super duper small Python script, and I want to be able to, so one thing about Docker is that each image, you can't edit the image. Once it's built, you can't edit the image unless you volume mount. And this is a concept that I found very, very, very helpful when just doing basic Python projects at work or anywhere. Like, I would like to -v my Docker run in order to volume mount my stuff. And what this does is it takes your current directory, instead of building an image, it takes your current directory and mounts it to the Docker container. And this is super helpful because say I was like, I'm writing this code over there and it doesn't work, or I want it to do different things. It has to build because you're mounting it, you're not specifying in a Docker file that you want them pre-built. So you're building your packages, and now I can run my Python 3 main.py, and it should have hello world come out because that is what it built. It built with that. Yeah, so you see that hello world come out here. And so now we can just directly edit our files and run that same main.py and get our Dijkstra's algorithm, which in this case doesn't just do this, but also builds a Dijkstra graph output, which when you're volume mounting, you can actually see what Dijkstra's does when it volume mounts, and it's just going to stick it into your local drive because it's connected. And that is where, when you're building Python projects and you want to use an environment that's like a container, it's super helpful to have like your own Python project where you're building your stuff and editing and changing all of the stuff, and then a place where you can execute it. And so, yeah, that is my basic tutorial on Docker.